Jupiter, the giant of the solar system, a world that has captured the imagination of humankind for centuries, a swirling mass of hydrogen and helium. Its ever-stormy atmosphere a reminder of the violent, dynamic forces that shape the cosmos. A gas giant, with a mass more than twice that of all the other planets combined, Jupiter is more than just a planet. It's a force of nature in its own right. But what if Jupiter weren't a gas giant at all? What if, instead of being a colossal ball of gases, Jupiter transformed into something far more familiar to us? Something solid, something terrestrial. What if Jupiter became a rocky planet? It's a concept so far removed from the natural state of Jupiter that it seems almost impossible. Yet, imagining this transformation gives us a unique perspective on the nature of planets, the forces that govern them, and the ways our solar system could evolve. Jupiter's size, its core, and the mystery of what lies beneath its thick clouds have intrigued scientists for decades. But imagine, just for a moment, if those clouds were gone, stripped away by some cosmic event. A new, rocky world would emerge, but with it, a host of new challenges, consequences, and possibilities. Jupiter's core is believed to be a dense mixture of metals and rock, hidden beneath the thick atmosphere of hydrogen and helium. It's the heart of the planet, a potential goldmine of resources that we could scarcely imagine. If Jupiter's gaseous envelope were to suddenly vanish, a rocky planet would take its place. But how could such a transformation occur? For Jupiter to become solid, we would need something catastrophic to happen. A massive collision, perhaps a collision so powerful that it strips away the gas and leaves behind only the dense, rocky core. The surrounding hydrogen and helium would be cast into space, dissipating into the void. Without its gaseous layers, Jupiter would shrink in size. What was once a planet with a diameter more than 11 times that of Earth would shrink dramatically, though it would still be far larger than Earth itself. This solid core would be far denser than any terrestrial planet we know, likely made of a mixture of rock, ice, and metal, with pressures and temperatures unlike anything we encounter on Earth. This newly transformed world might resemble a terrestrial planet, but one shaped by forces and conditions far beyond our current understanding. What would life be like on this newly born rocky world? A Jupiter now bereft of its clouds would become a completely different kind of planet. Without its gaseous atmosphere, there would be no great red spot, no dense storms swirling endlessly across its surface. Instead, the planet would become a barren world, its surface scarred by impacts from space debris, craters large and small, all marking the passage of time. The surface would be rocky and cold. Unlike Earth, there would be no protective atmosphere to trap heat, no thick layers of gases to maintain a habitable climate. The temperatures would likely plunge, rendering the surface inhospitable to life as we know it. Imagine standing on this new rocky Jupiter. There would be no winds, no clouds above to block the view of the distant stars. Instead, you'd be staring up at a cold, lifeless sky, with nothing but the barren rocky surface stretching beneath your feet. Jupiter's gravity, still immense, would remain a defining feature. While the planet itself would shrink, it would still be far more massive than Earth, resulting in a stronger gravitational pull. You would weigh far more than you do on Earth. But beyond the physical changes, there would be no familiar sights, no turbulent atmosphere or thunderous storms, just a world that feels strangely still, almost as though the universe had stopped moving. Yet, in its stillness, there would be a sense of awe, a sense that we're standing on a world of raw power and potential. one that has existed for eons but is now something entirely new. The implications of such a transformation would extend far beyond the planet itself. Jupiter, as a gas giant, exerts a profound gravitational pull on the entire solar system. Its gravity helps to stabilize the orbits of the other outer planets and even plays a role in protecting the inner planets, like Earth, by deflecting asteroids and comets that might otherwise collide with us. Without its vast, gaseous mass, this new rocky Jupiter would lose much of its gravitational influence. The outer planets, Saturn, Uranus, and Neptune, would feel the difference. Their orbits might shift slightly, perhaps even becoming more unstable. The asteroid belt, once under the watchful eye of Jupiter's gravity, could shift, sending debris toward the inner planets, creating a more chaotic environment. One of the most profound consequences, however, would be on the moons of Jupiter. These moons, Europa, Io, Ganymede, and Callisto, have existed for billions of years, tethered to their parent planet by its immense gravity. Now, with Jupiter reduced to a smaller, rocky world, these moons would find themselves in a new, unfamiliar environment. Would they continue to orbit as they once did? Or would their paths shift, pulling them toward a new fate? Europa, with its frozen oceans, might become an entirely different world, its interactions with Jupiter's remaining gravitational field potentially turning it into a more Earth-like environment, or perhaps, just as easily, a frozen wasteland. The orbits of these moons would no longer be as stable, and some could even be ejected from Jupiter's orbit entirely, hurtling off into the emptiness of space. Jupiter's moons were once at the heart of the mystery and intrigue surrounding this giant planet. Europa, with its hidden ocean, might have been a potential cradle for life. But what now of these moons? Without the immense tidal forces from Jupiter's gas envelope, moons like Europa could lose the warmth that keeps its oceans liquid. Could this lead to the loss of any potential life on Europa? Or, in a strange twist of fate, could these moons evolve in ways we never anticipated, becoming more like Earth's own moons, stable, cold, but perhaps still alive with secrets beneath the surface? Io, the most geologically active of Jupiter's moons, would also be drastically impacted. Without the constant tug-of-war between Jupiter's gravity and its internal heat, the volcanoes that define Io's surface might cease, leaving the once fiery moon a frozen, desolate rock. Ganymede, the largest moon in the solar system, might undergo a similar fate, losing much of the dynamism that once made it so intriguing. Would these moons drift into deeper space, forever changed by their parent planet's transformation, or could they, in their new orbits, find new paths to survival? Only time would tell. But one thing is certain: the changes to Jupiter would be a pivotal turning point in the story of the solar system. Jupiter, transformed from a gas giant into a rocky world, would irrevocably alter the balance of our solar system. A planet that once shielded the inner worlds from cosmic threats would now be just another world among many, its protective role no longer a factor. And the moons that once circled it like faithful attendants, they would face new fates, some becoming lifeless worlds, others perhaps finding new opportunities for life to take root. But the solar system and the universe are always in flux. What began as a dramatic shift in one corner of space would lead to a cascade of changes across the entire system. And perhaps, in the grand scheme of things, this transformation would spark a new chapter in humanity's exploration of the cosmos, an invitation to venture beyond the familiar, to seek answers in a universe constantly evolving. What would the solar system look like without Jupiter in its gaseous, protective form? A little less chaotic, perhaps, but far more mysterious, full of potential and challenges. The universe is a place of constant change, and with every shift, a new adventure is born.